Here's something that's breaking every rule we know about comets. 3. I/ATLAS is dying. Its brightness is fading, its main tail is disappearing, and it's cooling down as it moves away from the sun. That's exactly what should happen. But here's the problem. One part of this interstellar visitor is doing the complete opposite. Its sunward-facing tail, the one pointing back at the sun, is getting bigger and brighter every single day. This shouldn't be possible. When comets die, everything dims together. So what's really going on here? Let's dive right in. To understand why this Sunward Tail is so bizarre, we need to go back to September 7th. That's the day 3 I/ATLAS stopped following the rules. This interstellar visitor was first spotted on July 1st, 2025. For weeks, it behaved exactly as expected, steadily brightening as it approached the sun, following the pattern every comet in history has followed. Scientists were comfortable. They understood what they were seeing. Then, at precisely 2.5 astronomical units from the sun, everything changed. The entire object suddenly exploded with brightness, surging by 2 apparent magnitudes. Imagine if the moon became 4 times brighter overnight. That's the scale we're talking about. And this wasn't one spot or one jet, like normal cometary outbursts. The entire surface of 3 I/ATLAS erupted simultaneously. What astronomers witnessed was global cryovolcanism, violent sublimation of ice across the entire surface at once. But here's what sent alarm bells ringing. It never stopped. Normal comets have outbursts that fade within hours or days. 3 I/ATLAS's brightness kept climbing, kept accelerating, all the way through its closest approach to the sun on October 29th. Amateur astronomers captured massive jets extending 50,000 kilometers, 4 times Earth's diameter. This object was hemorrhaging material at a rate nobody could explain. Then it passed the sun. Like every dying comet in history, it should have started fading uniformly. The main tail pointing away from the sun began to dim. The jets weakened. Astronomers started writing their reports. But that sunward tail refused to cooperate. While everything else dims, that single feature pointing back at the heat source keeps growing brighter. Every single night it defies physics a little bit more. I need you to understand how fundamentally weird this is. The data shows 3 I/ATLAS rotates every 16 hours, which means solar heating gets distributed evenly across its surface. When that global eruption happened in September, it made sense because every part received uniform radiation. But physics has rules. As an object moves away from the sun, it receives less energy. Period. Temperature drops, material ejection decreases. The anti-sunward tail is correctly following these rules. It's fading because there's less material being ejected. Yet somehow the sunward tail is getting stronger. Something is actively forcing material back toward the sun with increasing intensity, even as the object receives less energy to do so. Dr. Sebastian Voldmer's December 1st image shows this tail more clearly than anything before. It's becoming the dominant feature of what should be a dying comet. The answer might lie not in what's happening now, but in what happened millions of years ago. Based on the Gaia star catalog, 3 I/ATLAS hasn't passed within 500 parsecs of any star for at least 10 million years. Some estimates suggest this object has been drifting through interstellar space for 3 to 11 billion years. While life evolved on Earth, 3 I/ATLAS was out there in absolute darkness. Not the darkness we experience. We're never far from starlight. I'm talking about darkness where the nearest star provides less light than a candle across a football field. In that darkness, something was happening. The interstellar medium isn't empty. as 3I/ATLAS drifted through cosmic fog for billions of years. It was accumulating material, layer upon microscopic layer, volatiles, ice, organic compounds from dying stars, building up a crust that has never been processed by stellar radiation. The surface is carrying material that hasn't seen starlight since potentially before our solar system existed. Then, on October 29th, our sun bathed it in 735 watts per square meter, compared to 10 to the minus 7th watts in deep space. It's like taking something from a deep freeze and throwing it into a furnace. The ancient crust didn't just melt. It explosively sublimated, revealing chemistry that has astronomers quietly rewriting their assumptions. Spectroscopic analysis revealed something shocking. The carbon dioxide to water ratio was 8 to 1. Normal comets, maybe 0.5 to 1. But 8 to 1 is 4.5 standard deviations above normal, a screaming anomaly. The carbon monoxide ratio was similarly bizarre. And then there was the nickel. So much nickel that researchers initially wondered if they were seeing something artificial. But there's a natural explanation, and it's fascinating. In Italy, there are extremely rare meteorites called CR carbonaceous chondrites. These aren't typical space rocks. They formed outside our solar system's protoplanetary disk before our sun and planets fully formed. And they have the exact same chemical signature as 3I/ATLAS. High nickel, oxidized compounds, carbon-rich chemistry. It's like looking at twins separated at birth. These chondrites contain reactive iron-nickel metal that, when exposed to liquid water, undergoes specific corrosion. The result is rapid formation of magnetite, Fe3O4, the most powerfully magnetic mineral we know. And in forming magnetite, hydrogen gets freed from water molecules. That free hydrogen, with carbon, oxygen, nitrogen, phosphorus, and sulfur, all present in carbonaceous materials, forms increasingly complex organic molecules through catalytic reactions. This is documented chemistry. What we're watching with 3I/ATLAS is a life chemistry factory running in real time. On December 2nd, NASA released findings from OSIRISREX that altered everything. Samples from asteroid Bennu contained every single building block for life: ribose, glucose, 14 essential amino acids, all 5 nucleotide bases for DNA and RNA, and water. Here's why this matters. Bennu is a B-type asteroid, heavily processed by solar radiation. It's been baked and depleted. If you were looking for organics, it would be one of the last places you'd check. Yet, there they were, all the building blocks. Which raises an obvious question. If a sun-damaged B-type has everything needed for life, what about a D-type object that spent billions of years in pristine interstellar space? 3I/ATLAS has the spectral signature of D-type objects, found beyond Neptune. These objects have distinctive dark, reddish surfaces from organic-rich crusts built up from interstellar material. If Bennu, a relatively barren rock, has all life's ingredients, then 3I/ATLAS, which spent eons accumulating molecules that cosmic rays processed into complex forms, could be carrying concentrations that dwarf anything we've seen. As magnetite crystals form across 3I/ATLAS's surface during catalytic reactions, something remarkable happens. You create a magnetic field. Comets generate induced fields from ionized plasma. The Rosetta mission measured 30 to 50 nanotesla normally, jumping to 300 when hit by solar storms. But that's external. 3I/ATLAS is potentially generating its own field from magnetite across its entire surface, layer upon layer of magnetic crystals as reactions continue. The combined strength could be substantially higher. And here's why that's profound. Life requires protection from cosmic radiation. High-energy particles cause DNA breaks. Too much radiation and self-replication becomes impossible. Earth exists because our magnetic field shields us. Mars lost its field billions of years ago, and its atmosphere was stripped away. We're potentially watching an interstellar object that, through pure chemistry, is building the same protective mechanism that makes life possible on Earth. Creating organic molecules while simultaneously building a shield to protect them. That's what the chemistry tells us is happening right now. So here's where we are, an object that spent billions of years accumulating organics, contains all building blocks for life, underwent massive cryovolcanism that activated catalytic processes, producing magnetite and building a magnetic field, has liquid water in certain zones, generating complex molecules through well-understood chemistry. At what point do building blocks become life? This isn't rhetorical. This keeps astrobiologists awake. We know amino acids form in space. We know nucleotides form. We know in the right conditions, these molecules spontaneously combine into complex forms. But where's the line? Is there a barrier requiring something special, or is it simply time and conditions, with complexity building until something can replicate? We don't know. And right now, with 3I/ATLAS, we might be watching it happen. On December 19th, 3I/ATLAS makes its closest approach to Earth, 103 million kilometers. Not visible to the naked eye, but close enough that Earth and the comet align with the Sun. That alignment might matter more than we realize. Something strange has been happening with solar activity. Major sunspot groups kept forming as they rotated into view of 3I/ATLAS. Large comets inject charged particles into the solar wind that can interact with the Sun's magnetic field in complex ways. Then comes the direct impact. From March to April 2026, Earth passes through the zone where 3I/ATLAS had its violent eruption. Those 50,000-kilometer jets. All that material is distributed along the orbital path. We're going to fly through it. We won't see glowing skies. The material is too diffuse. But we'll be flying through organic molecules from another star system. Complex chemistry built over billions of years, then processed during a close solar approach. Some of those molecules will enter Earth's atmosphere. This raises a serious question. Is this how life spreads through the galaxy? Not through advanced civilizations, but through natural processes. Comets carrying chemistry from star to star, depositing building blocks on every planet they encounter. Every star system has comets. Some get ejected into interstellar space. They drift for billions of years, accumulating material. Eventually, they enter a new system, get heated, release their cargo. It's not intentional. It's chemistry plus orbital mechanics plus time. And if that's how it works, then every planet with the right conditions has been receiving deliveries since the galaxy formed. Which brings us back to that impossible sunward tail. One possibility is magnetic. Magnetite crystals creating localized fields that interact with solar wind in unexpected ways. The wavy filamentary structures in the jets support this. They are characteristic of plasma following magnetic field lines. Another is pressure. Volatiles trapped below still sublimating from residual heat. If specific vents are oriented sunward, material ejects preferentially that direction. As the rest quiets, these vents become more visible, or, the possibility harder to dismiss, we're watching chemistry that continues operating as the comet cools. Catalytic reactions aren't purely thermal. They're driven by chemical potential energy in those reactive nickel-iron compounds. As long as there's liquid water contacting those compounds, reactions continue. Material actively produced and ejected, powered not by solar heat, but by chemical energy locked in the comet's composition. If that's happening, we're not watching death. We're watching a chemical process that will continue after the comet leaves our system. The life factory keeps running, building complexity, potentially crossing thresholds we don't understand as it drifts back into darkness. Latest images show the Sunward Tail now dominates 3I/ATLAS. It outshines everything. As this object continues toward Jupiter in mid-March, then leaves forever, we'll be tracking this tail, measuring its brightness, composition, structure, trying to understand what we're really seeing, because right now we're watching something that breaks the rules, a dying comet with one part that refuses to die. And the longer we watch, the more it looks less like death and more like something else entirely. So here's what we know for certain. 3I/ATLAS is dying, but one part of it is getting stronger every day. We're 2 weeks from its closest approach to Earth on December 19th. Then in March and April, we fly through the debris it left behind, organic molecules from another star system raining into our atmosphere. Is this visitor carrying the seeds of life? The chemistry says it's possible. Is that sunward tail evidence of processes we don't understand yet? The data suggests yes. Will we figure out what's really happening before it leaves our solar system forever? That's the race we're in right now. Every night, astronomers are capturing new images. Every week, the mystery deepens. And honestly, that's what makes this so exciting. We're watching something unprecedented unfold in real time, and nobody has all the answers yet. I'll be tracking every development as this story evolves. If you want to stay updated on 3I/ATLAS and everything happening in space right now, hit that subscribe button and turn on notifications. Drop a comment below. What do you think that sunward tail really is? And if this video got you thinking, share it with someone who needs to know what's coming through our solar system. The universe doesn't wait for us to understand it. It just keeps revealing mysteries. And this one? It's just getting started.